Hello, this is the lesson for Chapter 13, Tolerances and Fits in Machine Design. These are the sections we're going to cover. First of all, the objectives. Second of all, factors affecting tolerances and fits. We're going to talk a little bit about production processes and costs and how they relate to tolerances. Then basic sizes. We're going to talk a little bit about clearance fits, interference fits, transition fits, and a little bit about general tolerancing methods. Now what I want you to do is go ahead and print out your objectives, your objective sheet for Chapter 13, and follow along here. This narration is going to cover the first two objectives, and the first one is define the tolerance, the terms tolerance, allowance, unilateral tolerance, and bilateral tolerance, and secondly, describe the relationships among tolerances and how they relate to production processes and the costs of those processes. Here's some of the terms that we're going to talk about in this lesson. First of all, let's talk about the factors affecting tolerances. Variation of actual clearance in production parts depending on where the mating components fall within their tolerance bands. So what we're talking about here is parts that have to fit together, whether the parts have to move, or whether or not you're mounting a gear onto a shaft and it's a press fit. So we're talking about how parts fit with each other. So the second one is mounting power transmission elements in the shafts. Then you have to consider the fits and the tolerances of the mating parts. And then when relative motion between two parts is required, you're going to need a clearance fit. Okay, so a couple terms here. The first one is unilateral tolerance. That's where the tolerance deviates to only one side of the basic size. I'm giving you an example here. This one's a 1/4 inch, which is one of the preferred basic sizes, plus 10 thousandths minus nothing. Okay, so that is an example of a unilateral tolerance. And then the next term is a bilateral tolerance. They deviate on both sides of the basic size. So I've got two different bilateral tolerances here. One is 0.254 plus 6 thousandths minus 4 thousandths. That's a bilateral tolerance. And the other one is a unique case of bilateral tolerance, and that is 255 plus or minus 5 thousandths. And we're going to call that an equal bilateral tolerance. Okay, so a couple more terms. Total tolerance. That's a difference between the maximum and the minimum permissible dimensions. Okay, so in this particular case, all three of these cases here, the total tolerance is 10 thousandths. Another term I want you to learn is allowance. Now, allowance applies to mating parts. Okay, so the allowance is the intentional difference between the maximum material limits of the mating parts. And we're going to illustrate that later. So if it's a clearance fit, it's the minimum clearance fit. Okay. Fit. The term fit applies to the relative looseness of a clearance fit or the relative tightness of an interference fit of mating parts. It's very costly to produce components with very small tolerances on dimensions. We're going to talk about that in a little bit. Production of parts with small tolerances require multiple processing steps. Like for instance, you have a hole and you have to hold a really tight tolerance on the diameter of the hole. What you're going to have to do is drill the hole and then ream it to size. That's an example of multiple processes required for tight tolerances. Now let's talk about the tolerance grades. So tolerances produced with approximately equal production capacities. And these tolerance grades on table 13.1 is measured from 00 to 7. Okay, so rough saw parts, cast material as supplied, so that's where they fall within these tolerance zones. And then here's some tolerances for some tolerance grades. Okay, so as you can see, as you go up, these are in inches, here's would be the tolerances. Okay, so as your tolerance grade goes up, then your tolerance goes up with it. So that's tolerance grades. And then here's a slide on metric tolerance grades too. what I'm going to talk about now is tolerances as they relate to processes and costs. This is a very interesting slide. I want you to take some time with it and look at it a little bit closer. Okay, so what we have here on the Y scale is increase in machining costs. As you can see, as you go how tight the tolerances are across the x-axis, the cost goes way up. Okay, so as flame cut, that's rough, or forged and as cast, sawed, you have really, really generally large tolerances. And then as you start working your way up this chart, you're talking about grinding and honing and lapping and super finish. And in each case, you get a better surface finish, and you also get a tighter tolerance. And then you can see as the cost goes way up based on that. This last slide of this lesson, and again, it's just a lot of the same information, but it's processed differently. It's kind of like for metrics here, metric parts. And so you got flame cut at the top, and that's really, loose tolerances. And by the time you get from polishing and lapping and super finishing, you have really tight tolerances. So that ends this lesson. There'll be one more to finish this presentation.